Alright guys, here's the part 4 video of exercises 4.3. We're going to be going over 16 through 20 in this video. For number 16, I've got 3x is less than or equal to negative 5 over 4. Now this involves a little bit of dividing fractions, which you guys, if you're here, you've done before. We did a little bit of remediation, and so hopefully just it does not freaking you out anymore. But I know and you know that if we've got 3x, we're going to need to divide by 3 in order to figure out what x is going to be equal to. So, and again, I'm not going to do that problem for you, but I'll do something very similar. Let's do negative 7 over 3. So, in my example, I'm going to need to divide both sides by 2 in order to get the x by itself. And because it's a positive 2, sign's not going to change. And then over here, dividing by 2, I'm not going to necessarily put it underneath, because then you have a fraction and a fraction, which looks kind of funky. It is understandable, but it does look kind of funky. So what you do instead is you can put divided by 2. Remember, it's a whole number 2, so it goes up top. And then after that, we can do a keep, change, flip. And then you can see that this is not as tough as it seems. It's just going to be negative 7 over 6. And that's already, you can't simplify those numbers any down, but you can turn them into a mixed number, because 6 goes into 7 one whole time with a remainder of 1, so it becomes negative 1 and 1/6. Now let me show you what we would have done if we had decided to put the number underneath. So let's say that we had decided that we're going to put this number underneath. Well, because this is a fraction, its own fraction, and then this is the bottom of a fraction, that over 2, that's the denominator of a fraction. What you do is you take that denominator of the fraction and you put it into the denominator, so like that. And then you're going to do multiplication. You're going to do 3 times 2, and you're going to get negative 7 over 6, which is what we got originally, which equals negative 1 and 1/6. So when you're dividing a fraction by a whole number, really you're multiplying it by the reciprocal of that number, and so you're going to be putting that number in the denominator and multiplying it by whatever denominator is already there. So I just want to show you both ways of doing it. And so you're going to do that same kind of technique with this 3x is less than or equal to negative 5 over 4. Okay, number 17, we've got 4.2y is less than or equal to negative 12.6. Looks like I'm going to be doing some decimal multiplication or division here. I've got 4.2y, so I'm going to make up 3.6, and then that's going to be, I'm going to use the letter A for angel, is less than or equal to, let's make it 10.8. So 3.6a is less than or equal to 10.8, and it's a negative 10.8. And then we are just going to continue doing this kind of talk where if we've got the 3.6 on the top, we need a 3.6 on the bottom in order to get the a by itself, which is a division problem by a positive number, so the sign's not going to flip. And then the negative 10.8, that is going to be divided by 3.6. I'm going to do that over here off to the side. Top number on the inside, bottom number on the outside. This is a negative divided by a positive, so my answer is going to be negative. I can write that down already. And then now I need to turn this 3.6 into a whole number, so I'm going to move it over one space, that decimal over one time, which means I'm going to move this decimal over one time. And then so I end up with the question of how many times does 36 go into 108? And 36 goes into 108 3 times, because 36 times 3 gives me 108. And this was, we said a negative 3, so my answer is that a is less than or equal to negative 3. And then if a is less than or equal to negative 3, that's going to be a closed circle. And a is less than negative 3, so that's going to be to the left. So you're going to use that same kind of technique on number 17. Just remember that you are properly dividing your decimals by turning that outside number into a whole number. I just want to speak quickly on something. Let's say that you had 3.2 on the outside and then 3.51 on the inside, or 3 2/10 and 3 51/100. Then if I need to move this decimal over one space, I'm not going to move this decimal over 2 spaces, which I see some people do because they think, well, that inside number has to be a whole number too. But that would be false. however many times you move the outside is however many times you move the inside. The outside determines how many times we move the inside number, not the other way around. Alrighty, number 18. Now we've been working with a lot of decimals being next to the variable. Now we're working with decimal being underneath the variable, so underneath that b. And if we were to knock this one out, let's actually work out this one together. 11.3 is greater than b over 4.3. Because this one already has the 4.3, that decimal underneath the variable, I need to put that same number above the variable. I need to put a 4.3 up top, which we've discussed is multiplying by 4.3, because this is technically a 4.3 over 1, which gives you 4.3b over 4 3/10. And then those 4 3/10 on the bottom and the top are going to cancel out, and that leaves you with just b. And it's a positive b, so I'm going to leave the sign the same. And then now I need to also multiply this 11.3 by 4.3 and determine what that answer to that is. Now when we're multiplying decimals, I tell you guys to treat this just like any other problem, so ignore the decimals for a little bit. So we're going to do 113 times 43, which is going to give me 4,659, but then now this is where we put in the decimals. We see that we've got, I think I did something wrong here. Let me double check my math. So 3 times 3 is 9, 3 times 1 is 3. Oh, right here. This should be a 3, and so that makes this an 8. So we got 4,859, and then now we need to count how many numbers were in the decimals place originally. Well, over here we had one number in the decimals place. Over here we had another number in the decimals place, so a total of 2, which means that for my answer, I'm going to start at the very right and then move in 2 places. And so my answer becomes that b is less than 48 59/100. And then this is what we're going to go ahead and put into the solution, and then we're going to graph it into our number line. Okay, exercise 19. Which best describes the error in solving the inequality? So this one, I'm going to let you guys do this one by yourself because I really like these problems. Remember, the easiest way to figure out what they did wrong is to actually do the problem yourself and see, okay, what did they do differently from me, and why is that wrong? And so it gives you a few examples onto what might be wrong. It gives you a hint. So if you are a little lost on when you're doing it, what you can do is you can go ahead and take a look at the examples that are given. -9 should be divided by 3 and see should that be divided, or x should be greater than a positive number, and then we check that. So I'm going to let you do that one by yourself, and then you are going to need to work it out, so you're going to have to correct the error. But I really like these kind of problems because they make you think. They make you assess your knowledge with their knowledge. So go ahead and try that one on your own. Okay, number 20, it's been a little bit since we've seen one of these. So write the word sentence as an inequality, then I actually want you to solve out the inequality. So it says here, the quotient, remember quotient means quotient equals division. The quotient of a number, x and 4, is at most 5. So I'm going to do a different example. In my example, I'm going to put that the quotient of a number, so I'm going to still use quotient, of a number y and 5 is at most, so I'm going to do at least 7. So I'm going to use my example to kind of talk you through what you're going to do in this example. So I still have the same first part that I'm using quotient, means I'm going to be dividing two numbers. So the quotient of a number y and 5 is at least 7. So that's pretty simple to knock out. I can put that all down, but I need to figure out what does at least mean. Well, I need to think about if at least, what does that mean? So let's say that you go to the store and to buy a new t-shirt costs at least $20. So it costs at least $20. That means it either costs $20 or it costs more than $20. It might cost 21, might cost 22, 23, but it's not going to be, unfortunately, anything underneath $20. It's not going to be 19. So you definitely won't catch me buying this stuff. But it's going to be either 20 or higher than 20. So that means either equal to or greater than. And so I would write here, I would make a combination of these both, that y over 5 is at least, that means that it's either equal to 7 or greater than 7. And so that's kind of how you can reason through it. Kind of think about real case scenarios, like what is at most something. Maybe if I said, Mr. Albanez will pay at most $5 for a sandwich, then think about that. What kind of amounts will I pay? What kind of amounts won't I pay? And then use